our next lesson and the last lesson in Module 4 is about dividing segments proportionally. And this covers one CCRSM standard, and that is GPE 6, find the point on a directed line segment between two given points that partitions the segment in a given ratio. Let's get started. Lesson 12 starts off with a question about midpoint. But I don't want to talk about midpoint. I want to talk about dividing this segment proportionally. So I'm going to change question number 1 to be this. Find the point on segment ST, where S is -2, 8, and T is 10, -4, that divides the segment in the ratio of 1 to 2. All right. Now I've drawn that on a graph over here to the right. You do not have that in your materials, but you can go ahead and draw that if you want. So what I'm looking for is the point on the line segment. I'm not sure exactly where it is right now. That'll divide the segment so that this, whatever length that is, this is twice as long, or I'll call it 1x to 2x. So whatever length that'll divide up into a ratio of 1 to 2. Now we could use the distance formula to look at distances, but that would get really difficult really fast because the distance formula is not really a simple formula. It's kind of complicated. So what we'll look at instead is dividing up the x, the x coordinates, looking at one dimension of the x dimension, and looking at the y dimension, the y coordinate separately. Okay, and that'll divide it up pretty easily. So let's use some numbers here. In the x direction, I start at -2, and I end at 10. And so the length here, this length, has a length of 10 minus a -2, which is 12. It's 12 long. Okay, and I'm looking just at distances right now. Now the length of 12, I can divide up so I have one part to two parts, but what I'm really looking at is dividing it into thirds, okay, into 3 parts, so I have a 1 part and a 2 part. Now if I look at, I'm still looking at distances, if I take 12 and divide by 3, I get 4, which means each of those parts will have to be 4 long. So this would be 4 here, and this would be 8 here. So again, I have the 1 to 2 ratio, 4 to 8. Again, that's just distances. Now, looking at coordinates, from -2, which is where I started from, I'm going to add 4, and I'm going to get 2. And that is the x coordinate of my mystery point. Now, in the y direction, we do the exact same thing. I start at the point of 8, and I end at -4. And I've traveled a distance of, let's see here, 8 minus -4, the distance would be 12. And that's the distance. And again, I want to divide this into by 3 because I have 3 total parts. And I get 4. Okay, so from the starting point, 8, I want to go down 4. 8 minus 4, which gives me 4, and that is the y-coordinate of my mystery point. So the point on segment ST that divides the segment in the ratio of 1 to 2 is the coordinate 2, 4. Okay, now I like the picture and the graphical representation because I'm a very visual learner. Okay, so I might sketch a graph regardless of what I'm doing, but this is a little complicated. So let's break this down and perhaps create a formula that we could use to figure this out. Okay, so we started with the ratio. Okay, the ratio of 1 to 2, and we quickly found that the number 3 was very important because that was the total in the ratio. Okay, and from the starting point, I was looking for 1 out of that 3. So this ratio, 1/3, was really useful in the ratio, okay? 1/3 of what? Well, 1/3 of the difference between, the starting point and the ending point, okay? So in this case, I could have used 1/3, and looking in the x direction, for example, I could have found it by 10 minus a -2, and that would have given me 1/3 of 12, which is 4. That would give me this number right here. And then looking at this, I started from the very starting point, -2, and I added that. So in my formula, I have x sub 1, or y sub 1, plus my ratio, which will be the first number divided by the total, parenthesis, x sub 2 minus x sub 1. Let's kind of use that as our formula. It'll work for either x or y, depending on what x or y is in the formula. Let's try this for y to see if it works. So y sub 1 is 8 plus. The ratio is 1 to 3, the first number divided by the total, parenthesis, x sub 2, or y sub 2, is -4 minus 8. And what that'll give me is 8 plus 1/3 of -4 minus 8 is -12. 1/3 of -12 is -4, so I have 8 minus 4, which gives me 4. And that worked out exactly what I did before. So this formula here, which by the way, I'll never give you on a exit ticket or on an assessment, you have to memorize this formula. But hopefully, by talking it through, that you start somewhere, you start at x sub 1 or y sub 1, and then you add to that the ratio times the difference between the x's or the y's. Okay? So let's try this on the second problem, which is a little more complicated. Number 2 is find the point on the directed segment from -2, 0 to 5, 8 that divides it in the ratio of 1 to 3. Now 1 to 3 has a total of 4. So if I divide it into 4 parts, then I have a 1-part and a 3-part ratio. All right, this is x sub 1, y sub 1, x sub 2, y sub 2. Let's try this out for the x's. So if I start with -2 plus, the ratio I'm looking at is 1 to 4. 1 to 4 times, it's x sub 2 minus x sub 1, which is 5 minus -2. And I have -2 plus 1/4 of 5 plus 2, which is 7, for space, is 7. So I have -2 plus 7/4. Now, -2 in fourths is twice the number of fourths, which is 8/4, plus 7/4 is -1/4. That's the x coordinate. The y coordinate will be y sub 1 plus the ratio y sub 2 minus y sub 1. That's our formula in terms of y. So plugging those in, I have 8, just kidding, I don't. I have 0 plus 1/4. Y sub 2 is 8 minus 0. So I have 0 plus 1/4 of 8 minus 0, which is 8, which is 2. So putting those together, I have -1/4, comma 2 is the point on the directed line segment from -2 to 0 to 5, 8 that divides it in the ratio of 1 to 3. All right, there's one more problem that I want to look at that's not in Engage New York, but it is on the Park assessment. And I'm going to use this space over here to do it. So jot this down in your notes. Given segment AB, where A is -1, 4, and B is 3, 2, find point C on line AB so that the ratio of A to B, AB to BC is 2 to 3. Now this is a bit different. Let me sketch a picture so we know what we're looking at. So I have a point A, which is at negative 1, 4. That's A. And B is 3, 2. That's B. And somewhere on this line is a point that's called point C. I'm not sure where it is, but it's over here somewhere. So that this length AB to the length BC has a ratio of 2 to 3. Okay, so it's a similar problem, but it's different because C is not in between A and B. So the formula we just derived doesn't actually work because our ratio in that formula will always be less than 1. In this case, the ratio has to be more than 1 because I'm going outside of the distance from A to B. In fact, the ratio I'm looking for, again, has to do with the total, as it always will. Okay, and I'm looking for the ratio is not going to be 2/5 like before because it's outside of the two segments. It's going to be 5/2. So this ratio, the same ratio, just upside down when the point is not in between the two given points. Let's try this with the ratio of 5/2 because the point I'm looking for, C, is not in between A and B. So I'll start off, again, I have x of 1 plus the ratio, and here's my ratio, times x of 2 minus x of 1. So if I start there, I have negative 1 plus 5/2 times 3 minus negative 1. And that gives me, let's see here, negative 1 plus 5/2 times 4. And half of 4 is 2. And so I have negative 1 plus 10, which is 9. And in the y direction, I have y sub 1 plus the same ratio, 5/2, times, y sub 1, y2 minus y1, which is 4 plus 5/2 times 2 minus 4, which is 4 plus 5/2 of negative 2, and half of negative 2 is negative 1, so I have 4, negative 1, minus 5, which is negative 1. So the point C, will be 9, negative 1. So the point of that is, be very careful about this formula. It's a great formula, this and this, but if the point you're looking for is in between the given points, then it will be a ratio less than 1. If it is a point that's outside of that segment, then it's going to be the ratio that's more than 1, which is total divided by the first number. All right, this video was about dividing segments proportionally. Thank you for watching.